Chapter 15, Trace Minerals, Screencast 2. This screencast will be focusing on two trace minerals. Those are zinc and copper. First thing that we want to point out here is that the best sources of zinc are going to be protein, and it could be either animal-based protein or actual plant-based protein. Two good sources of plant-based protein include black-eyed peas and sunflower seeds. What we see here as the biggest source of protein would be a 3-ounce serving of oysters. Zinc is absorbed in the small intestine by both diffusion and active transport. There is something known as cysteine-rich intestinal protein, and metallothionein are produced in enterocytes to actually bind to zinc. Absorption will be impacted by diet composition and the body's needs for this particular mineral. Absorption will increase when intake is low and need is elevated, and like many other minerals, when zinc or non-heme iron is excessive and phytic acid is high. So this is a table similar to what we saw previously for iron. Factors that will increase the absorption of zinc will be low to moderate zinc intake, a deficiency in zinc, certain amino acids, and someone that has an increased need for zinc. Factors that decrease absorption are phytic acid and fiber in whole grains, excessive zinc intake, high intake of non-heme iron, and good zinc status. Now, when we look at the role of zinc, there are quite a few functions. It plays a role in the synthesis of DNA and RNA, the formation of bones, taste acuity, the synthesis of heme. It is associated with immune function, reproduction, growth and development, plays a role in our antioxidant defense network, will stabilize gene transcription and receptor proteins, and also there is evidence that it shortens the duration of the common cold. Now, this is purely anecdotal evidence, and one of the things that I have noticed when I first feel the symptoms that I generally experience when I feel a cold coming on, one of the things that I grab for is a zinc supplement. And my experience, keep in mind, once again, this is anecdotal, once I take zinc, when I first experience symptoms, what I have noticed is that the cold is never as severe, and also I tend to recover more quickly. So please keep that in mind. Now, the symptoms associated with zinc deficiency are wide and varied. If we look at delayed growth and sexual maturation, loss of appetite, dermatitis, it will impair the function of vitamin A, alopecia, there's going to be a decrease in taste sensitivity. Wounds will not heal as well. Our immune system will not function as properly. We will be looking at diarrhea and the potential for both birth defects and increased infant mortality. Now, when we look at zinc toxicity, the upper level is set at 40 milligrams per day. Symptoms of toxicity include loss of appetite, nausea, vomiting, intestinal cramps, diarrhea, impaired immune function, and also there's going to be reduced copper absorption and activity of copper-containing enzymes. Now, for the most part, notice that these symptoms are rather vague and could be associated with many other deficiencies. So please keep in mind that when we start talking about toxicities and deficiencies of minerals, they are very vague and general primarily. Now, the next trace mineral that we want to address in this screencast is copper. So once again, if we look at the best sources of copper, they are going to be coming from proteins. Once again, both plant-based proteins and animal proteins. And if we look at oysters, once again, they are an extremely good source, but not as good a source as beef liver, if we look at the amount of copper that is found in that particular organ meat. When we look how copper is absorbed, as usual, it is absorbed by diffusion and active transport processes taking place within the small intestine. In the bloodstream is how it's transported, and it is going to be bound to albumin and other proteins. Liver is the main storage site. It will be transported from liver bound to ceruloplasmin, and this is another mineral that will be excreted through bile. Absorption will increase when dietary copper is low, and it will decrease when intakes of copper, iron, zinc, and phytic acid are high. Now, the functions of copper are wide and varied, and if we look at one of the biggest, it is an important component of many enzymes. Ceruloplasmin, this will oxidize ferrous to ferric. It plays a role in superoxide dismutase, and that will eliminate superoxide free radicals. So that's part of our free radical defense system. Cytochrome C oxidase will catalyze the last step of the electron transport chain. Monoamine oxidase enzymes will regulate the amount of neurotransmitters, and lysyl oxidase will actually help form connective tissue. Deficiency of copper is rare, but it may occur in premature infants that are fed a milk-based formula, infants that are recovering from malnutrition, long-term parenteral nutrition, so being fed through a tube, excessive zinc intakes, and a disease known as Menkes disease. Symptoms will include anemia, leukopenia, and osteopenia, loss of skin and hair pigmentation. There will be some changes in the cardiovascular system, and once again, we'll see an immune function that is impaired. Now, toxicity is rare, but it may be seen in accidental overdose in children. It could be due to consumption of copper-contaminated food or water, or a disease known as Wilson's disease. Toxicity symptoms include abdominal pain, nausea and vomiting, diarrhea. Severe accumulation of copper in the liver and brain will actually cause cirrhosis and significant neurological damage. The upper level for copper is 10 milligrams per day.